light behaves not only like a wave, but also like a particle, they have made another astounding discovery. They found that particles, the most elementary building blocks of our universe, form a distinct interference pattern when fired through two slits. A pattern that is typically created by waves.
And this observation tore the scientific world into two opposing camps. One side following Albert Einstein and the other standing behind Niels Bohr, who famously remarked, "Everything we call real is made of things that cannot be regarded as real."
Indeed, Niels Bohr, to Einstein's dismay, claims that each electron is a blur, a wave probability, passing through both slits simultaneously. The particle seems to be everywhere at once and only decides a specific position when measured on the screen behind.
Essentially, this means that there is no concrete reality, only the potential for an infinite number of outcomes. And nothing is ever decided until someone observes it. And this is one of the biggest mysteries in science today. A substance that is so elusive and yet makes up 68% of the matter in our universe, compared to only 5% of the normal matter as we know it. Dark energy is evenly permeating our entire universe, but it is an unseen material with a vast array of unknown properties. Scientists theorize that it is responsible for counteracting gravity and causing the accelerated expansion of our universe. Even though it is capable of pushing stars and galaxies apart, when astronomers calculated the strength of the dark energy, the result was an incredibly small value. However small it is, this value has huge implications for our universe. If it was any lower, the universe would simply collapse. But if the value was higher, space would be expanded at such a tremendous rate that matter would not be able to form, clumping would not occur, and life as we know it can simply not exist. In an attempt to explain why this amount is exactly what it is, scientists are considering the possibility of a multiverse.
According to string theory, all matter is made up not of quarks, but of open or closed strands energy. These superstrings vibrate at different frequencies, and just as a string of an instrument creates different notes, the properties of the string change according to their vibrations.
While Einstein's general theory of relativity would work in an unlimited number of dimensions, string theory, or M theory, can only exist in 11 dimensions. These dimensions are infinitely small and convoluted for those right beside us, imperceivable to our human senses. The defining element of our universe is the shape these dimensions take. Depending on their form, a universe has different properties. The problem is that scientists found so many ways these dimensions could curl up that only the existence of a multiverse could explain this gigantic number. Every shape could be a reality in one of the countless universes.
rise to an infinite number of universes, with ours being only one bubble in an ever-expanding fractal of universes. These other universes could have very distinct laws of physics and fundamental constants, making them look vastly different from our observable universe. However, with an infinite amount of universes and a finite amount of ways matter can arrange, there is almost certainly another version of each of us. The quantum universe is easily one of the most perplexing theories of all. It predicts that everything that can happen does happen in a multitude of daughter universes that form every